everything? Yeah, sometimes I just do her homework for her. All right, so yesterday we started integration by substitution. I'm over on page 29, which is sadly, the last integration skill that I need to build with you all. For Roberto, there's 3 or 4 more. Okay, we are never, even Roberto and all of his brilliance back there, you are never going to get to the point where you can integrate as many things as you can find the derivative of. At this point, you guys can find derivatives of just about everything on the planet, except for the hyperbolic functions, because you don't even know what those are. Someday, Calc 2, Calc 3, you'll study the hyperbolics. You can take the derivatives of like everything. Integrals are really tricky, and I'd say there's like a very small bucket of ones that you can solve. You, of course, know at this point in your life that the integral of sine of x is... Negative cosine. Oh my gosh, the integral of sine of x is what?
Negative cosine.
Really? Negative cos x?
Yes.
God rest Charlie. Yes, plus Charlie. We know that the integral of secant of x times tangent of x with respect to x is...
Secant of x. Plus Charlie.
Secant of x plus Charlie. We know that the integral of 1 over x squared plus 1 with respect to x... No, there's nothing natural about what you just said. The integral of 1 over x squared plus 1 with respect to x... Yeah, clearly we've got some more studying to do. Those are the baby ones. Those are the baby ones. And so then yesterday we started talking about integration by substitution. And integration by substitution, what I want to remind you of is the uglier the integrand is, the more likely substitution is the way that you're going to go. The more stuff there is there, the more likely substitution is the way to go. To use integration by substitution, you need to find the baby and the derivative of the baby. As Sylvia said so well yesterday, we're like unchaining. So with that said, take a moment, look at this first problem. Is this integration by substitution? Is integration by substitution the way we want to go? If so, what's the baby? And do you see the derivative of the baby? Okay, can you oh, yeah. 29. If this is going to be substitution, you need the baby and the derivative of the baby. Anybody find the baby?
Find the baby and the derivative of the baby child.
Let me give you a little bit of a nudge. That's sine squared. Another legal way that you can write this is sine of 2 theta squared times cosine of 2 theta. Right, sine squared just means sine of the whole thing squared. Anybody see the baby now? Hopefully everybody sees the baby now, except like Rebecca and Diego and folks that were absent. Right, what's the baby?
Sine 2 theta.
Okay, so if u is sine of 2 theta, if that's true, then I'm also going to find the derivative. I want to be really careful here with the derivative. I'm taking the derivative of u, but what's the variable that I'm interested in? Theta. So this is du d theta. We take the derivative and you get cosine of 2 theta. Be careful. Times 2. Everybody okay with the selection of the baby? Okay. So, well, what's your next move? The next move is to actually physically rewrite this integral in terms of the baby and the derivative of the baby. So rather than sine of 2 theta the whole thing squared, well, I'm just going to call that u squared. Well, what about cosine of 2 theta? Oh, bummer. I've got cosine of 2 theta times 2. What I want is to be able to rewrite cosine of 2 theta, but I have cosine of 2 theta times 2. If only there was some legal thing I could do to get the cosine of 2 theta to show up.
Like that 2.
You could factor out the 2. That's not going to be nearly as helpful as, Gonzalo, what do you want to do?
Multiply the whole thing by half.
Okay, is multiplying the whole thing by half, is that legal? This is legal. You may not see it. First, like, well, why did you just do that? By doing this, now what you're saying is that a half of du d theta is equal to this expression over here, cosine 2 theta. That allows me to be able to rewrite my cosine of 2 theta in terms as this 1/2 du d theta. The d theta at the end, I'm not too worried about right now because I think you guys all know what's about to happen to it. What has to happen to that d theta?
Cancel.
It's going to have to cancel out. And oh, look, it actually does, so that's pretty good. What you're left with is the integral of u squared times 1/2 du. U squared times 1/2 du. That 1/2, we've talked about this a lot already, like it's a constant. I can factor that constant out in front. So we've got 1/2 the integral of u squared du. That's pretty good. What has u squared as its derivative?
1/3 u cubed.
Right? This should be a power rule kind of thing. You've got your variable raised to a power, and the power rule says add 1 to the power, divide by the new power. So you've got 1/3 of u cubed. Don't forget about that 1/2 that you're going to multiply by, plus Charlie. If you multiply this out, you're going to get 1/6 u cubed plus c. That looks pretty good. And most of you seem like we're pretty much okay right now. But we know not to stop here. Right, if you started off your life in terms of theta, you're going to end this problem in terms of theta. So I'm going to make this 1/6, and what is that, sine of 2 theta of the whole thing cubed plus Charlie. You can take a derivative and check it if you want to, but have faith, that actually is going to be the antiderivative. That's substitution. You're going to look at some messy integral. You're going to look for that baby from the chain rule. You're going to look for the derivative of the baby from the chain rule. And you're going to rewrite your integral in terms of u because it becomes a lot simpler, maybe a lot more obvious how this is going to work. All the friends are mostly okay? Okay, here's what I want you to do. I want you to find an eyeball partner. Somebody that you are not currently sitting with. You're not going to say anything and be like, Chris, bro, dude. Let your eyeballs make the appointment. Find somebody you're not currently sitting with. Holler at them with your eyes. You're going to work with them for the next 37 minutes, so make sure it's somebody that you want to work with, some quality individual. Everybody move. Go find your partner. No.
I know.
You cannot work with somebody that you're already sitting with. Everybody's going to move.
No, you don't have a partner here. No. Wait, what's your partner? I thought you were. No, that's not.
Oh, Karina. Karina stole someone's partner. In a minute.
Still recording?
Yeah, so we sit together.
This girl is still recording?
Yep, definitely recording. Alright, everyone's sitting down in 3. And 2. And 1. Okay, since we get eyeball partners, the person with the prettier eyes, your partner A. The person with the ugly eyes, your partner B. Alright, closing out in 3, 2, and 1. Okay, here's what's going to happen. If you're partner A, you're going to work on this problem while partner B works on this problem over here. You're working on different problems. When you're done, when you're each done, you're going to swap papers, check over the work, and give each other feedback. I'm only going to give you guys 8 minutes total to do round 1 and round 2. Partner A, pretty eyes. You're going to do this one. Partner B, ugly eyes. You're over here. You have to do the switch. You have to do the feedback. This is how you're going to grow. Get going.
I'll do it. Why don't we both?
So
Wait.
it's a little different because when you are doing one of the top functions,
And I'll do partner.
that's how you measure distance, top function by
I
function.
don't think you can.
Okay. Is Lucy okay? Oh, he's stuttering now.
He's really scared.
You're gonna be okay. That's okay. You should be. Yeah. That should be.
Like, how are you gonna start this? So I would look at this whole hot mess and see, is there anywhere where you have a baby? Oh, and
That's it.
I'm making fun.
I don't know, but he always laughing.
remember, places that baby likes to hide in the exponent, inside parentheses, in the denominator. These are all good places for that baby to hide. Are you guys?
You got an 80.
This is something different.
Floor. Don't miss on my floor. There's floor. Hold on. I want to adjust the expectations for
Before going to A&M, bro. It must mean something. You gonna put A&M?
Sorry. Yep.
So that's our find the baby and then you find
Find the derivative of
Ooh, why are you wearing that
and
trash, bro? Come on. It's like wearing the Obey though. Be wearing the Supreme. Come on.
Then you go back and rewrite the
so I have that
Absolutely.
Isn't it bigger?
Bigger don't mean better, bro.
Right. So this is quality.
yeah, that's what I just read. So
So rather than writing I'm going to write it in
I feel like it's a medical school.
So what
There's a lot of people graduate from one day into the medical school. And Baylor.
Baylor is more of an engineering.
Like when I was in Utah, you know what the Bible is?
They read no, that doesn't mean they no.
Yeah, the baby.
It has a clinic, but it doesn't mean it's
So
good.
use the baby and then
You will be sorry.
One second.
right? And you find the derivative, so you get this, right?
All right, little nudge for partner A if you're still stuck like Chuck.
So this, right?
U is going to be 3x squared minus 5. du is going to be 6x. But you only have x up here, so I would either say divide by 6 or multiply by 1/6. So you get 1/6 du dx is equal to x. When you do the rewrite, x is 1/6 du dx. We've got e to the u, and we've got the dx. And you know that everything's gone well because the dx's are going to cancel out. Hold on, Henry. Over here, partner B, u is 2t cubed minus 3t squared plus 2. du, be careful, du dt is that guy's derivative, which is 6t squared minus 6t. Oh, bummer, I don't have 6t squared minus 6t. I have t squared minus t. How can I get this to be t squared minus t?
Multiply by 1/6.
Multiply both sides by a sixth, or tell me divide by a sixth, it doesn't matter. So 1/6 du is equal to t squared minus t. When you do the rewrite, you're going to get 1/6 du dt over u times dt. Finish it up, keep going. No, you've done this work because this should be easier for you to work with. It should be easier to figure out what has 1/6 t to the u as the
Multiply by 1/6.
Well, because what you're doing is you're looking at the integrand. You're saying, what is it that I have over here? I have t squared minus t. How do I change the derivative of the baby to be t squared minus t? I have 6t squared minus t. How do I get to t squared minus t? Divide both sides by 6.
Yeah, we're trying to get this equation.
So you'll tell me.
How would you know for sure?
I'm kidding.
Why'd you put back the...
Yeah, then you find the aggregated. It's just a method to find it easier and faster.
The way that you're going to know for sure is you're going to don't forget about Charlie.
Where'd you get the 6x from? Because I took the derivative of 3x squared minus 5, and that derivative was 6x.
Look, give us the notes.
Perfect. 1/6 is the absolute value. That's not your final answer.
Love it. Keep going. Round 2.
So you know same thing we learned when they were
Why did you do the 1/6?
Oh, no, right here. This is here.
because we're learning credit card instead of credit cards over there.
Okay, what are we working on?
Working on this.
Okay, then let's keep going. Let's keep the conversation moving. Let's not waste too much time.
Alright, so
I think so.
you
I can't read upside down. Is that
Oh, okay. So what's the baby name?
It's the bottom. Yeah. It's based on...
When du over u, du over u with the for
let's say one more.
Alrighty, friends, time is up. If all went well, round 1, partner A, you got 1/6 e to the 3x squared minus 5 plus Charlie. Okay, round 1, partner B, you got 1/6 natural log absolute value 2t cubed minus 3t squared plus 2 plus Charlie. How many of the partner A's get their problem right? How many of the partner B's get their problem right? Okay, not as many as I was hoping. Okay, round 2. I don't think many of you got there. I want you to get this copy down in your notes so that you've got access to this for later. If I'm going to do the round 2 partner A problem, I hope the baby is somewhat obvious. Right? The baby's underneath the radical sign. So the baby is 2 sine theta minus 1. Then you find the derivative and you get 2 cosine theta. Du d theta is 2 cosine theta. What are we going to do? You're going to multiply by 1/2 to get this cosine theta. Your final answer, feel free to just jot down what the final answer is going to be 3/4 of 2 sine theta minus 1 to the 2/3 power plus c. This would be a great practice problem for you guys to do. For partner B, probably the selection of the baby here is also pretty obvious. The u is going to be 1 plus sine of 2x because that's what's in parentheses. That's one of the places the baby likes to hide. If I take the derivative is 2 times cosine of 2x. I only have cosine of 2x, so I'm going to multiply both sides by a half. Your final answer is going to be negative 1 over 2 times 1 plus sine of 2x plus Charlie. I want to leave those up there so you can get them copied down if you need to. We've got about 25 minutes left. We're going to continue in the world of integration by substitution, but it's going to be a little bit different. There's a little bit more of a nudge coming your way right now. Just give me a quick tap on your nose when you are done copying down whatever you need for the notes. It's negative 1 over 2 parentheses 1 plus sine 2x. Just quick tap on your nose when you're done copying this down. It's all those done. Whoever this girl up front is, Sheila Boyanis, who also sometimes is Sylvia or Marilyn. But I don't think I've ever called you anything other than that. Okay. All right, friends, it's going away in 3, 2, 1. All right. So now here comes the push. So far, what kind of integrals have we done? Indefinite integrals. I want us to focus on the definite integral type. And let's just see what we can do. You want to trust your smarticle particles here. Now, 1 and 2 are definite integrals. I'm going to work through these together, and then you guys are going to get some practice time. The definite integral from 0 to 1 of x over x squared plus 1, the whole thing cubed. What's different between a definite and an indefinite integral? What's different? Destiny, what's different?
The definite integral, you're trying to figure out how much area is bounded.
Right, this is an area question, but in terms of process, is there anything different? Is there anything different between definite and indefinite integrals?
No.
There really is no difference. The only difference is once you find the antiderivative, you're going to plug in the numbers?
Yeah.
Right? All right, let's do it. So for those of you that like equipped with all the smarticle particles and you think you know what you're going to do, feel free. Everybody else, stay with me. I need to find the integral of x over x squared plus 1, the whole thing cubed. I hope, since we're in integration by substitution mode, what's going through your head right now is, gosh, can I do substitution here? If you're going to do substitution, where's the baby? And you know that you've got the right baby if you also see the derivative of the baby. How many are pretty sure you see the baby? Karina sees the baby, Daisy sees the baby, ladies up front see the baby, Rubio thinks he sees the baby. Jose, what do you think the baby is?
X squared plus 1.
Okay, so Jose thinks that the baby is x squared plus 1. He might be right, he might be wrong. Michelle, I'm going to know for sure that he selected the right baby after this next move, which is we take the derivative. I'm going to find du dx, and du dx is 2x. If I select this as my baby, and this is the derivative, can I rewrite this whole integral in terms of u?
C did.
Right? I've got x over here, but wait, I'm supposed to have 2x. I think we know how to fix that. You're just going to multiply both sides by a half. So now a half of du dx is equal to x. Hopefully this is becoming a little more friendly, a little more comfortable. All right, let's do the rewrite process. In the rewrite process, rather than x, I'm going to put in a half of the u dx. In the denominator, I'm not going to write x squared plus 1 cubed anymore. I'm going to write u cubed. And I'm going to write that dx for right now, but I think everybody knows what's about to happen to the dx. It's going to cancel, and that's a good thing. Now, here's something that's different when it comes to definite integrals. If you're going to do this the right College Board way, where you get all the points, it's not just about the integrand being rewritten in terms of u. The limits of integration have to change as well. What I just said is this. When you're doing your integration in the beginning, you're saying go from x equals 0 to x equals 1. But now I'm over here in green. Everything's in terms of u. Your limits of integration have to be in terms of u as well. Well, x was equal to 0. What's the u value? If x is equal to 0, what's u? Not 0.
1.
It's 1, because what we know is that we've established a connection that u is really the same as x squared plus 1. So u is 0 squared plus 1, we get 1. Down here, u is 1 squared plus 1, and you're going to get 2. Your new limits of integration are u equals 1 to u equals 2. So that's a place where it's a little bit different. We have limits, and we're going to deal with the limits. Well, let's keep going. What else could we do? What other legal things could we do to integrate here? Gonzalo, what do you say?
You could take out the 1/2 since it's a constant to the outside.
Right, that constant, that 1/2 is a constant, so I can pull that outside. So I've got a half the integral of 1 over u cubed du from 1 to 2. I need to integrate 1 over u cubed. What has a derivative that's equal to 1 over u cubed? Resist the temptation to say natural log of the absolute value of u cubed, because it's not that. Have a quick conversation with somebody near you. How would you do that? The integral of 1 over u cubed. It's not natural log, no matter how hard you want to try that. Not ln. Alright, most folks seem to have figured it out. You want to rewrite this as u to the negative 3? Because now you can use your power rule. Power rule says add 1 to the power and divide by that new power. To divide by negative 2 means multiply by negative 1/2. Don't forget about the half out here that you're supposed to multiply by. And don't forget about your limits that are from 1 to 2. Is everybody okay with the integration?
Yeah.
If you're okay with the integration, then you know exactly what to do next. Right, we're going to plug in the 2, we're going to plug in the 1. Right, you're going to subtract. So I might even clean this up and say negative 1/4 u to the negative 2 from 1 to 2. Big parentheses minus big parentheses. Negative 1/4 times 2 to the negative 2 minus negative 1/4 times 1 to the negative 2. That's good. If it's free response, I'd stop. I wouldn't do anything more. If it's multiple choice, 2 to the negative 2, I need you to do something with her.
1/4.
2 to the negative 2. Is it the negative exponent that's thrown, everybody?
Yeah.
Get rid of the negative exponent. 2 to the negative 2 is the same as 1 over 2 squared. 1 to the negative 2 is the same as 1 over 1 squared. So this should be negative 1 over 16 minus negative 1/4. So negative 1/16 plus 1/4. Get a common denominator. And you're going to get 3 over 16. Henry, what's up?
What happened to the du from as the so before you plug in?
Right, like why am I not writing the du over here anymore? When you actually do the integral, right? So like from here to here, what you did is you found the antiderivative. You stop writing the du because the du is there to say, hey, u is the variable. Everybody okay? Now, there's another question that I thought somebody was going to ask. Because there's something that we normally do that we didn't do here. Marilyn, what's your question?
For you did rewrite it as x squared plus 1.
Right, normally after you do the integration, right, after you like find the antiderivative, you'd say, oh, let me put in u and say u is x squared plus 1. But that's because that's when we're at our stopping point for an indefinite integral. You want a function. Here with the definite integral, because you changed your limits of integration to be in terms of u, Your final answer is going to be a numerical value. It's going to be an area. With definite integrals, once you change over to u, you don't have to change back. Ever. Okay, let that sit for a little bit. All right, I want to see what you guys think about number 2. Have faith. Have faith in your smarticle particles here. Some people are pulling out their integration foldable. Some people are flipping back. They're like, hey, what does have tangent of theta as its derivative? Other folks have figured out the key to this problem. The derivative of tangent is secant squared. You want the antiderivative.
You don't want to say it. So what function is you said? Not what's the derivative.
All right, just did a quick stroll. And what I keep seeing is secant squared theta, and that's no good. I think all the secant squared theta people are getting confused about which direction we're going here. The derivative of tangent is secant squared theta. I want the antiderivative here, so stop at secant squared theta work. That's not it. Integration by substitution. Usually there's the baby, and there's the derivative of the baby, and I'm starting to hear whispers in the room of some genius move that you could do that would be helpful. Look at that integrand. Is there anything you could do that might move you forward? One person's got some thoughts. I heard whispers some other sides of the room. Diego, what are you thinking about here? Oh gosh, not that. Not cos over sine. Consider your source next time. Okay. Okay, so first of all, is it legal to rewrite tangent of theta as sine theta over cosine theta? Is that legal?
Yeah.
That's legal, it's a trig identity. Second question, is it helpful?
Yeah.
Why?
Because there's a baby.
Now you see the baby, right? What's the baby? U is the cosine of theta. And the derivative of the baby? Du d theta is not sine theta. It's the negative of sine theta. What you have in your integral is sine theta. What you have down here is negative sine theta. I think we can fix that. Right, you could like multiply both sides by -1. So -1 du d theta is equal to sine theta. In your rewrite, rather than sine theta, you're going to write negative du d theta. The cosine of theta is the u, and the d theta stays d theta for right now. You've almost completely, perfectly rewritten the integral. Almost. Henry, what's missing?
The variables, 0 and pi over 4.
Okay, they're not the variables. These are the limits of integration.
Oh, yeah. The limits.
Right, because these guys are thetas. Theta is equal to 0. Theta is equal to pi over 4. I need u. Well, how it worked before, theta was equal to 0. Theta is equal to pi over 4. How do I get the u values? You're going to go back over here because this is where you link the u and the theta. So if u is cosine of theta, then this is going to be cosine of 0. This is cosine of pi over 4. And cosine of 0, everyone who survived trig or can find the the poster's been taken. Cosine of theta we know.
1.
Is 1. Cosine of pi over 4? is square root of 2 over 2. So 1 to square root of 2 over 2. Okay, finish it off.
I took out.
Okay, seeing a lot of good stuff happening.
Negative times. Oh, and you
Wait, what did you do?
D thetas are going to cancel each other out. It goes from 1 to square root of 2 over 2. Negative du over u. If you want to write that a different way, u goes from 1 to the square root of 2. This is the same as negative 1 over u du. That du is usually the last thing. What do we know of that has negative 1 over u as the derivative?
Negative natural log.
It's the negative of natural log of the absolute value of u. So this is going to be negative natural log absolute value of u from 1 to the square root of 2 over 2. Plug in big parentheses minus big parentheses, negative natural log square root of 2 over 2 minus negative natural log of 1. If you're worried about, hey, wait a second, what just happened? Aren't there supposed to be absolute value bars there? Sure. But it's also okay to drop them. Why can't we drop them? Why don't you need them anymore? Flora, why don't you need them anymore? That's not why. But good try. Thanks for getting in there. Why can I stop writing these things? Jackie, why can I stop writing them?
Because both u equals square root of 2 over 2 and 1 were already positive, so there was no need to.
Right, these are already positive numbers. What's the absolute value going to do? Nothing at all. Okay, in terms of simplifying, I would want you to simplify a little bit further. You could say negative the natural log square root of 2 over 2 plus the natural log of 1. And I'd hope you do one more thing. I mean, you can do that, but there's something a little more obvious here. Something I would hope is more obvious for you guys at this point. I see, Jackie, I'm going to ignore you for a little bit. There's something that should just be right on the tip of your tongue. Daisy, what you got?
I was going to say, since like they're both natural log and they're adding to like square root of 2 over 2 times 1.
So Karina said that as well. The problem is this negative in front actually messes you up. Because you could rewrite this as natural log of 1 minus the natural log of the square root of 2 over 2. And then you'd have to do subtraction. The thing I was hoping for is right here. Natural log of 1. What? 0. If only you weren't so loud all the time. Okay, 0. So your final answer is negative natural log square root of 2 over 2. Yeah.
Couldn't you also bring them together or something like that? Because I know when they're subtracting, it'll be like square root of 2 over 2.
Okay, and that's the thing that's been brought up a couple of times. If you had natural log of square root of 2 over 2 plus natural log of 1, you could combine them through multiplication. But this negative in front is going to mess that up a little bit. Rather than talking too much more about the log properties, I want you guys to get some more practice. Okay, so if you flip the page over, there are some practice problems, not nearly enough time for you to do all of them. That's okay. I think in the last 6 minutes, you guys should be able to do 1 and 2. It gets better with practice. It gets a little more obvious.
What's the U? The U is a base.
It's the derivative of something. Exactly. Look messed up.
But it would be, the derivative of u would be 2 at 1/2.
Oh yeah, it is.
Okay, no, look, and you want to
weren't even here today.
look.
Hey, take it off. Get your haircut.
Exactly.
I'm sorry.
Looking good?
Go ahead. I get lost now. Okay, so okay, do that was you do.
Gonzalo, thank you for reminding me why I have assigned seats.
Oh, wait, so the U.
Why is it over?
Why is it over?
Girl, if you want yeah, that's
But I mean,
yeah, that's what she did. She tried on you.
this is how it's works. No, I haven't got that done.
You have to
Check it out.
Okay, so
Yeah.
I want to stop the conversations just for a second. How many of y'all honestly made it to this step? So you identified the baby, you get the derivative of the baby, and you change the limits of integration. One more time, how many guys honestly made it here? Okay, we're doing pretty well, we're moving in a good direction. Often, and this is why I make a big deal, some of the calculus teachers might be like, but why do you change the limits of integration? When I was in high school, we didn't bother changing the limits. The College Board for the last couple of years will sometimes ask on the multiple choice, they'll say like, here's the original integral, which of these answer choices is equivalent to what you started with? Right, we're thinking like multiple choice and matching. And a common thing that they're going to do is they're going to give you guys this as the answer choice. And they're awfully close. They're awfully, awfully close. And for the calculus teachers who tell their kids, don't worry about the limits of integration, what happens, they pick this one, and they're absolutely wrong. Because the key with substitution, when you do the substitution, everything changes. The integral is in terms of u, the limits are in terms of u. I want to make sure that everyone is making that change in the beginning, and then you finish it off. Now from here, well, what are we going to do? You're going to integrate from 9 to 25. I'd probably rewrite square root of u, oh, yikes, as u to the 1/2 so I can use my power rule. Power rule says add 1 to the power and then divide by the new power. Don't forget about that half. You're evaluating from 9 to 25. You can multiply these together if you want to. I know I'm going to do this part fast, but I think we're making a lot of progress here. Big parentheses minus big parentheses. 1/3 of 25 to the 3/2 minus 1/3 of 9 to the 3/2. 25 to the 3/2. 25 to the 3/2 means square root first. Square root of 25, everybody knows. 5. Raise it to the 3rd power. 5.
125.
Gonzalo Avalos, class of 2018 at Southwest. Don't make me shame you on camera. 5 cubed is not 15, it's 125. So 125 over 3. 9 to the 3/2 square root of 9 is 3. 3 cubed is 27. I think he said 11 this time. It's so bad. If you subtract those, 98 over 3. Monday, we're going to continue playing around with integration by substitution. You cannot afford to stick your head in the sand here. It's we'll edit that part out. And in case anybody's wondering what he looks like, here he is. Here he is. This is Gonzalo saying all the wrong things today.
There you go.
Exposed.
I'm the smart one.
That's what they say, cheaters.